So I've done a talk for the last maybe 5 years called VST What the Fuck, and it was focusing on extraction and refractometers. And recently we've started focusing away from just talking about refractometers, because I think for a while they were the tool that was new and interesting, and they helped us learn some things, and we were focusing on the tool. But now I think it's time for us to just focus on the coffee and what's going on. And the refractometer is kind of like a secondary thing that allows us to measure some stuff. So tonight is mainly, I hope that you'll walk away from tonight understanding how extraction works and what our biggest struggles are to extract coffee really, really well. And that might sound really simple and lacking context, but I hope that by the end of tonight you'll understand what I'm talking about. I hope to dispel some myths. I hope to answer some difficult questions. Please, if at any time you do have a question, I encourage and prefer questions during the talk when everyone is in the same frame of mind and everyone's dialed into a certain concept. If you don't understand it, I'll have 4 other ways to describe it to you and different analogies, rather than at the end and then we have to sort of reframe and get back and waste some time and get back into it. So don't feel like an idiot if you ask a question. I didn't understand any of this at one point either, so I'm more than happy to bring you up to speed to where I am now. So please put your hand up or yell or whatever, and I'll happily stop at any point and answer questions. So let's begin. First up is strength of coffee, which we call TDS, or total dissolved solids, or it's the ratio of water to dissolved coffee. And this is real simple stuff. This is the most basic of starting to analyze and objectively appreciate coffee. Whenever I talk about strength today, I'm not talking about intensity. Intensity is this coffee is intensely bad tasting, or this coffee has an intense rubber flavor. That rubber flavor can be intense, but the coffee can be strong or weak. So whenever I talk about weak or strong coffee and strength, I'm talking about the TDS of that coffee. And whenever I say specifically intensity or flavor, that's when I'm talking about something else other than TDS, just to clear that one up. So when we're talking about strength for a filter coffee, it's probably going to be something like 98.6% water and 1.4% coffee. So coffee is an exceptionally strong flavoring agent compared to most other things that we cook with. Just a tiny little amount of it will flavor an entire mug of coffee. And that's pretty cool. So for espresso, it's even stronger at 10%. And it's actually really rare that anything in a chemistry lab or even nature approaches a 10% concentration when you extract it into water. It's quite a rare thing to have a solution with 10% total dissolved solids. So an espresso is kind of a rarity, and it's also one of the strongest things we taste in terms of the number of chemicals and what an assault on our mouth it is. But in terms of manipulating strength and moving with strength, it's so simple and easy. There's just a single axis that we can move up or down, more strong, less strong. So when coffee is not strong enough, I would describe it as weak, watery, insipid, thin, empty, and when it's on the less bad side of not strong enough, delicate or tea-like are also in there as well. So that's pretty easy. When it's on the strong side, heavy, overwhelming, and rough are the usual flavors we would use. And then intense, obviously I just said that I wasn't talking about intensity with strength, but when you have a strength that's intense, that's intense. So that, that doesn't count. And then bitter also has an asterisk because there are multiple kinds of strength in coffee, and one of them is when the strength is too high. And there's a certain threshold, and all of you have it, and every single one of you have a different threshold, where once the coffee exceeds a certain TDS, your tongue will just send the message to your brain, or your brain will interpret the message somewhere along that chain somewhere. Your brain says, no, that's too strong. And then you just taste it as bitterness. And the easiest way to ascertain whether it is indeed bitterness from strength rather than bitterness from some compound is to just dilute that coffee with some water and taste it again. And if the bitterness is still there, then you know that it's not strength. So there are lots of different kinds of bitternesses in coffee. And unfortunately, from a natural selection point of view, apparently, bitterness emerged as, don't eat that, it's poison. And because we don't die, we slowly develop an appreciation for bitterness and its various complexities. But bitter itself is still just a signal. It's a binary yes, no. Maybe it has some intensity in the information as well. So every time we perceive bitterness, sometimes we get clues from other flavors about what that bitterness is. Like if you have Campari, you're like, different herbs and bitterness, that's Campari. But with coffee, there's so much going on that sometimes you don't quite know what the bitterness is. So diluting your coffee can be an easy little trick to check if it's a strength bitterness problem. Now, when its strength is correct, I kind of like to refer to it as, oh, yeah, there was a hand. Hello.
Is that why, like, when you give an espresso to someone who hasn't had much coffee, that they're just like, oh, it's just bitter?
Yeah, like I hated my first Campari or my first Negroni. I thought it was disgusting. And then the next hot day, I was like, wouldn't mind some of that Negroni I had the other day. And it's like a slow appreciation for it. And you might find that those people haven't had much other bitter foods as well, whereas cocktail people seem to merge quite nicely into coffee because they've already started appreciating all of those bitter, interesting combinations of flavors, and chefs as well. So yeah, I think it's definitely a learned thing because natural selection tells us that's poison, get it out of your mouth, please. I like to think of correct strength as like the music in a venue. If you don't realize that the music's wrong, it's probably good. So when the strength of a coffee is correct, it's usually pleasing, mouth-filling, luscious, rich, nuanced, creamy. It's just good, and you don't need to think about it. It just is. And I think that's a really important thing. So in that sense, strength is easy. And that's all I'm going to talk about strength tonight. If you want to make it stronger, you use more coffee. If you want to make it weaker, you add some water. Strength is so simple. It is a one-dimensional line going up and down. For the rest of tonight, we're going to talk about extraction, which is far more interesting and has far more dimensions and complexities. So when I talk about extraction, I'm talking about your percentage extraction yield, or your yield, or how much of your dry dose has been dissolved in water and taken into the brew. That's what extraction is. Or how much flavor you've taken from the coffee is the opposite way to think about it. So extraction also has a nice, simple, one-dimensional flavor relationship. And we're going to start off with that, but then we're going to start adding more dimensions to it as we go through. So when an extraction is low, when we haven't extracted much, you might think of the last time you pulled a very short espresso. So not much water went through the espresso, and for some reason you tasted it. And it was probably sour, it was probably vegetal, salty, nutty. Two other words that I like to use for coffees that aren't extremely under-extracted, but you're still searching for what's wrong with it, is underwhelming. It's kind of like, oh, this coffee, it's a bit boring, there's not much going on. It's probably under-extracted. Or could be more is what a lot of people say when their coffee is under-extracted. They're like, oh, I just feel like there's more in this thing. It's usually under-extracted. Now, when extraction is too high, which isn't necessarily from the same, it's not like a linear relationship. You change some knobs on your grinder or whatever and you go from low to high. There's a lot of things going on. But when you do somehow over-extract coffee, maybe you boiled it in a saucepan, then it starts to go dry, it starts to go astringent, powdery, empty. And I mean powdery is in the texture, like as if you had a drink with cacao in it, like powdered cocoa. And once again, bitter with an asterisk, because over-extraction can sometimes be bitter as well. So bitterness, again, is a tricky one. Now, when extraction is right, and this is the key, is it's transparent. Now, the best analogy I've heard for this is from George Howell, of George Howell Coffee in the US. And he says that each step in the coffee chain is like a window, and that window can be clean or dirty. And when you have bad processing, you have a dirty window that looks back at the farm. And you're still, when you move further down the chain, you're still looking through that dirty window to the farm. So if you can clean every window, then your coffee becomes quite transparent and you can taste what's going on with it. And I would say that that is a very noble goal for specialty coffee, which I assume all of you are in. because as specialty coffee professionals, we need to justify charging more for our coffee than other coffees. And if it's not special and transparent and unique, then we're not really doing anything. And it's probably just, I don't know, our interior design or our marketing. So balanced, nuanced, tasty, aromatic, parts the clouds is another phrase that people use a lot. But I would have to say the most important descriptor for a correct extraction is sweet. Every time I've ever chased sweetness, any time we've ever ruthlessly tried to get more sweetness out of a coffee is when our extraction has increased and improved and become more even, the coffee has become more sweet. And I don't think I've ever heard anyone ever say that espresso was too sweet. Has anyone ever said that? I think I said it once for a filter coffee. So yeah, we have plenty of room to go with more sweetness. You can always find some more sweetness and no one's going to complain. So always be focusing on that sweetness. So there's another dimension to extraction, which is where we start getting a little bit more complex. That slide just slid in there. How do you measure extraction? How much have we taken from the coffee equals how much coffee is in the cup divided by how much coffee we used. Simple. We don't need to go any further into that though. So this extra dimension is why extraction is hard, because there's more than one extraction going on in our cup of coffee. So you could also say that extraction is uneven. It's always uneven, because every single coffee grind that's in every single one of your brews has a different diameter, a different shape. It reacts with water differently. Water travels through, past, into, and out of it differently, which means that our extraction isn't perfectly homogeneous like that last slide would lead you to believe. It's always a melange, a blend of all of those things. So when we have an uneven extraction, we have our classic under-extracted flavors, we have our classic over-extracted flavors, and what's left in the middle at the same time is muddled, unfocused. Some people would say it's complex. Some people actually aim for this flavor because it's really easy to hit, so then you're very satisfied all the time. It's so true though. And aromatic because it smells and tastes like coffee. Now this is probably every espresso you've ever had. Probably. And it's what a lot of people say is the espresso flavor, is actually just a big old mix of generic under-extraction, generic over-extraction, muddling up a little bit of correct extraction. And it's why a lot of people struggle to discern different coffees in an espresso machine. They're like, they just all taste like espresso. And some of you might have been a little bit embarrassed when you were tasting espressos and sort of thinking, these all taste the same, they taste like espresso. And that's okay because they probably did, and it's not your fault. So this is normal, but once again, we're specialty coffee. We're trying to be special and unique. If everything's generic, I can make the best geisha in the world taste unevenly extracted, and I can make the cheapest Robusta taste unevenly extracted. And they're both going to taste the same because those generic flavors can be in any coffee. And if that's not the antithesis of specialty, then I don't know what is. But luckily, we can improve this situation. We can improve our extraction and make it more even. Now, the beauty of making your extraction more even is that you actually get a twofold benefit. For every 1 unit of improvement you put into improving the evenness of your extraction, you get a twofold improvement in the flavor of that coffee. Because not only do you remove the generic bad flavor, maybe it's over-extraction or under-extraction, but the coffee that was contributing that over or under-extraction is now contributing a net positive benefit to the good extraction. So it's a -1 of the bad flavor, or it's adding 1 point because you got rid of a bad flavor and adding another point because you're adding good flavor. So there's not often in coffee where 1 unit of effort gives you 2 units of net gain. Usually it's marginal gains and we're squeezing to get anything out of it. So if there's one area where you can put in 20% of effort and get 80% of results, it's in making your extractions more even. So once you move to a more even extraction, you start to taste your coffee in high definition. I like to use the analogy of going from a VHS, and it's the same movie, but now you're watching it in HD. It's the same storyline, everything's the same, it's the same studio, but now you get to see everything in crystal clear clarity. Now that may mean that you're tasting the problems with your roasting or tasting the problems with the coffee from, and where it's from, but roast better and buy better coffee. That's your problem. It's going to be sweeter, it's going to be more intense and mouth-filling. So you've actually turned up the volume on the good flavor now. So before, where it was generic coffee, now you have really intense, unique coffee, which is hopefully what we're all trying to sell. Complex, rich, aromatic, no distractions is a really important one because there's none of those generic flavors, there's just the coffee. So you've really cleaned up that window and now you're serving the coffee that you said you were serving, and your customers are more likely to appreciate and understand that, there was some effort put into this. It actually does taste different. So even extractions are pretty key, but unfortunately, every single step in the supply chain all the way up to brewing the coffee introduces unevenness, and we have to control all of them lest we produce an uneven cup. So I'm just going to go through every single way that a coffee can be uneven, just to show you the gargantuan battle that you have if you truly want to eliminate all unevenness in a coffee. So step one is location. So if you have a regional coffee, whenever you have a coffee that's from Colombia called Cauca, or a coffee called Pirulito, or something like that, that is a region. That's potentially hundreds of farms, all of them at different altitudes, all of them with different drying. They've got their own little secadero out the back where they dry their coffee a different way. Different moisture percentages, different soils, different sunlight, different rainfall, different moisture, everything. And then when you start to slowly move down that line to micro lots, you get less and less and less uneven. Now this isn't necessarily saying that micro lots are better, but they generally taste more unique. And that's not, micro lots don't taste more unique necessarily because they're better or because anyone put more effort into them. It's because they're probably going to be more transparent because there's less distracting flavors. There's more uniqueness concentrated in a micro lot and less randomness in each cup. And that's probably why micro lots are usually more interesting. Now, estates or farms and plots are in the middle there as well. So you can divvy up your lot of coffee to be quite macro. It could even be like an entire state of a country, like in an Ethiopian coffee exchange kind of world, all the way down to micro lots. If you're lucky, that melange of flavor might be what your customers like. So you might have a blend of coffee that's a milk coffee, and to keep it consistent all year, you deliberately choose a regional lot so that it's more consistent, whereas micro lots will be quite varied all the time. It really depends, but it does introduce unevenness. Then, of course, there's different farms, altitude, soil, sunlight, plant ages, pruning, watering, different fertilization regimes, all that kind of stuff. All of it introduces unevenness. The variety, that's probably the biggest in terms of what is the coffee going to do, how's it going to react to the roaster, what's going to happen later, because that's at the DNA level of the plant. It's not just terroir, it's how is the cellulose in this bean structured, which is going to have a massive effect. So if you're aiming for a really intensely unique cup of coffee from Kenya, you don't buy coffee that's SL2834 and Ruiru 11. You would say, no, I don't want all those different varieties from the farm. I want SL28, please, thank you. And then it's probably going to be more unique and interesting. It might be more expensive, but that's the price you pay. In terms of processing, obviously, picking is huge, sorting is huge, how long is it fermented for, and what percentage is it dried to. Drying has a massive effect on Maillard reactions in a roaster. If some of your coffee is wetter and some of your coffee is drier, some of it will steam and some of it will cook. And that's going to have a massive effect down the line on your extraction. So this is all, again, unevenness. Packaging, usually that's okay because it's all in the same. If you buy a container of coffee, it's all packaged the same way. But if it's shipped for a long time and one end of the container was in the sun on the side of the boat, that's going to get cooked and then the moisture is going to change, the water activity is going to change, and then unevenness is going to occur. And then age, of course, as well. So there's a lot against the green buyer to get evenness in their coffee, but these challenges have been somewhat surmounted by good practices and good buyers, good farms who understand what's going on. But next we have roasting. So roaster design is generally pretty terrible for cooking coffee. We are currently, specialty coffee is currently using tumble dryers disguised as coffee roasters, and it's really just like a mass of beans at a 20-degree angle sitting in a tub getting spun around by some arms in a barrel with some hot air coming over the top. It is not even. If you showed that to a process engineer or a chemical plant engineer who designed, mass transfer or anything involving fluid bed design, they would laugh at you because it's just so uneven. The application of heat to coffee beans is horrific in drum coffee roasters. So that's against us. I honestly don't know whose fault it is that the specialty coffee industry uses drum roasters, but whoever it is deserves a lot of pain. Whoever bought the first Probat, or I don't know if Instagram was around then, but whoever did that, yeah, they deserve some pain. So we have development and solubility. If your roaster is accelerating towards the end of the roast, if you have a lot of heat being applied near the end of the roast, the outside of the bean will be more cooked than the inside of the bean, kind of like a steak. You don't want a charred, rare coffee bean. That's delicious when you have a steak, but you really just want like a awful boiled sous vide steak that hasn't been seared. That is optimal for coffee, and it's really hard to make that happen in drum coffee roasters. And then obviously, of course, blending. Yes?
You want the roast completely even through the bin?
Yes, absolutely. If I would, the Agtron color scoring thing, the machine that was actually designed for French fries for McDonald's. And it is a French fry machine. And it uses some specific wavelength of light or near infrared to measure the development of certain chemicals in coffee. And normally roasters will measure the outside of their coffee beans. They'll put the beans in a tray and slide it in the machine. It measures them. Then they'll grind the beans and put them back in. And they'll measure the difference from internal to external color. And a lot of specialty roasters pride themselves on having a big difference between those two numbers, and it's just underdeveloped and savory and awful. Those numbers should be theoretical identical. Otherwise, you're just inviting unevenness. And if you have an even roast, then you can choose to move it darker or lighter. But if you have an uneven roast, your freedom of movement of where you could have moved an even roast, darker or lighter, your freedom is now there. And whenever you make small adjustments, you're going to be very frustrated. So you want the inside and the outside to be identical, which is hard. But if you can get there, then you have so much more freedom and you're making coffee that tastes so much more delicious. It's really hard with drum roasters. Jeremy Challender from Proofrock, who I just hired, has a wonderful analogy for roasting. He says roasting in a drum roaster is like throwing a porcelain vase onto a shelf on the top of the bookshelf, and it has to land on the top of the bookshelf without breaking the first time. And you don't get any practice rounds. And it's kind of right, because it's so difficult to cook a little coffee bean the right way. And then people blend, and they'll deliberately blend a Brazil and a Kenyan, because they're like, I want a chocolatey coffee that's also fruity. But one of them's super dense, and one of them is super not dense, and they'll roast them pretty similarly, and then you'll have massive unevenness, once again, reducing your freedom to move around. And your Brazil will be over-extracted, your Kenyan will be under-extracted, and your actual average extraction is somewhere in the middle, and it's just not going to be great. So roasting adds another bunch of fun things to evenness. I can't wait for specialty people to use more fluid bed roasters. Yes?
Are you saying that there are people that would put two different types of bean in a roaster at the same time and roast?
That's even worse. I didn't even bring that up. Yeah, yeah. No, absolutely, because it's cheaper and easier to just pre-blend. Yeah, that's true actually. If you if you pre-blend your green, that's just adding even more problems, because if you were really good at blending, you would match the solubility and porosity of your different blend components by roasting them differently, perhaps to different times or temperatures, and then they would match each other once you started brewing them. And if you actually focus on that, the blends you start to make taste so good, but the amount of effort it requires to consistently match porosity and density of different coffees in a tumble dryer is like way too much effort. So nobody does it. We just kind of like hope that we're close. Yeah?
How would you measure the solid solubility of your roasted coffee?
I'm gonna get to that later. Yeah, because that's a new thing that we've started figuring out properly. So then finally is grinders, and grinders is where we're going to sit for a while, because that's probably what most of you have control over and what you can understand and what you can manipulate most of the time. I'm sure there's a few roasters here, but everyone here I'm sure uses grinders and has at least a little bit of an understanding. So extraction is an average, and that's why it's really hard to understand. It is not just a number that comes out of a refractometer. And that's also why most of the criticism I hear about refractometers is that it is just an average, therefore it'll never tell you what's actually going on. But an average will at least give you an idea of more or less, and that's really important. So when you have a lot of different grinds coming out of a grinder, you have small ones, bigger ones, way bigger ones on a 2 or 3 orders of magnitude in terms of microns. The smallest ones have so little mass and so much surface area, so their surface area to mass ratio is so out of whack that as soon as water touches it, it's fully extracted. There's almost nothing left to extract. Whereas when you have a very large coffee grind, that really tortuous matrix of cellulose is hard for the water to get into. It's not just going to freely dive in and then come back out again. And if you want an example of that, throw some coffee beans in hot water and see if you get a pour over. It's not going to happen because the water doesn't get into those coffee beans. So our extraction is going to be made up of completely extracted tiny grinds, less extracted slightly larger grinds, and very, very under-extracted large grinds. And as you'll find out soon, because of the way spheres work, this completely blows out of proportion once we start grinding with regular coffee grinders. And it's a real hassle to actually get full extraction out of our coffee grinds because of this problem. So this was actually the little card that I printed out for the judges at the 2013 World Barista Championship when I used an EK43 for making espressos. I was like, I don't think espresso grinders are probably optimal for extraction because of this. And it's really obvious. You've got a whole bunch of pebbles coming out of an espresso grinder and a whole bunch of dust. And with a filter grinder, you have a whole lot of really small coffee grinds. And the first time I ever made an espresso with an EK43, I hit 22% extraction, whereas I'd been struggling to hit 18% with a Robo. And I didn't do anything weird. We didn't change the grind. We didn't change the machine. We just presented the water with so much more surface area and so much less big grinds that our extraction yield went up. And the coffee tasted so much better. So this is a really basic example, a really big contrasting example of why it's better. But we're going to dig in a little bit deeper and start to really understand what is better, where does it become better, and why and how does that change occur with different grinders. So this is a classic particle. Yes?
I just wanted to ask, so if the grind makes such a big unevenness, should we all start applying sifters in the coffee shop?
No. That would cost a lot of money. But you can choose equipment and brewing practices that reduce the need to do that kind of stuff. And I'll definitely get into that later. So this is a classic particle size graph that would come out of a device called a laser diffraction particle size analyzer. So what it does is you grind some coffee grinds, chuck them in this machine, it sucks them through with a vacuum, shoots lasers at them, and because of the magic of physics, it measures the diameter of every single particle, which is pretty neat because I wouldn't want to do it by hand. So it pumps out a graph like this. Now, at the join of the axes, it would be 0 microns on the x-axis, all the way up to, that's probably a millimeter. Now, this is a logarithmic graph, So if that's 0 and that's 1,000, then that would be 10 and that would be 100 microns. So it's a scale of 10, a log scale. So in this particular example, on the y-axis is percentage or percentage volume, and you can pretty much just say there's more or less of them. Like that's the easiest way to think about that y-axis. So we have, in terms of volume, not in terms of count, this is just how much space do they all take up cumulatively. We have very little 0 to 100 micron, or 0 to 10 micron grinds. We have some up to 100. We have lots of volume between 100 and 1,000. And that's pretty classic for most grinders, and that's a problem. So if we put in this other line here, you'll see that it's very different in terms of the 10 to 100 micron range, and it's missing a whole heap of the probably 400 to 1,000 micron grinds. That big empty space up the right-hand side there. Now, for the longest time, everyone in the coffee industry would say the black line is superior because it has a taller peak. And everyone was very focused on the peak. The peak, the peak, the peak. And it turns out that the height of the peak of whatever your chosen grind setting is isn't really important. What's really important is what's your total standard deviation of every little extraction that's happening from all of these grinds. So how big is the distance from your most extracted grind to your least extracted grind? And can we manipulate that? So with this red line, we've reduced that standard deviation. Now this is really important. The reason we want to move this line to the left instead of eliminating all of this and moving everything to the right and making more coffee up in here is because these little grinds down here act and brew exactly the same way as the exterior of all of these. So a big grind doesn't all extract at 13%. It extracts at an average of 13% because the outside is at 28 and the inside is at 0. And halfway between 0 and 28 is 14. So that was a bad example, but 13, 14, 14%. That's why your big grind is at 13% extraction. It's not because big grinds extract at 13%. It's because water only penetrates a little bit into the big grind, leaves the rest alone, destroys the outside, and then leaves. And then your average is 13 or 14. So if these guys all down here are behaving exactly the same as the outside of these grinds, then really we should be optimizing everything to meet your maximum. So maximum is actually great because you were already extracting all of your grinds to maximum. It's just that your average of what you were missing, the inside of those grinds, was dragging your average down. Now I'm going to re-explain that in about 5 different ways over the next 15 minutes to make sure that you all completely understand what I'm talking about. Now the most optimal grind would be like that. And that's what you would see from something called a roller mill that they use to grind for like Nespresso capsules and high volume industrial grinding. And that's an extremely even, very fine grind size where everything is extracted to 26% and it tastes amazing, but unfortunately, they're really expensive and they're hard to fit into a room like this. So it's not exactly an EK43. So we just have to try and get there. We just need to try and optimize our grind and use brewing methods that move us down that way so that we can approach that optimum. So I'm going to explain it another way. Instead of looking at a graph, we're now going to pretend that coffee grinds are two-dimensional. They're flat, and the water's on the outside, and the coffee grind is just like a circle. So if we look at a coarse, a medium, and a fine grind in terms of we've sliced them, and we're looking at them as a cross-section, and we use white to black as our extraction, 0 being white, black being 28 or maximum extraction, you'll see a tiny grind is completely extracted, 28%. probably 25%, but 28% is our theoretical maximum. And the really fine grind only has a tiny little speck in the middle that hasn't been extracted a lot. The rest of it is completely extracted. Now you notice that that thickness is the same in the medium grind, but because the medium grind is larger, there's more of a space in the middle that has been less extracted. So therefore, the average extraction for your medium grind is less, but the outside still has the same level of extraction as this fine grind. And then as we go coarse, you'll see that thickness is still the same, but the inside is so large, there's such a large proportion of that grind that hasn't really been extracted that the average is taken down again. Now, cast your eyes to the colored band. This is what everyone thinks extraction is in terms of good and bad on the same axes. So because of this average phenomenon where our extraction number is just a mixture of everything, what it leads us to believe is that 0 to 18% is under-extracted, 18 to 23% is great, and then above 23% to 28% is over-extracted. And that's an illusion because of that average effect. What really happens, and what I strongly believe is the case, is that it's more like this. If you actually measured every grind to see how it was extracted and you could isolate it correctly, everything up until 18% would be under-extracted, 18 to 23% would still be under-extracted, and then 23% to 28% would be correctly extracted. Because remember, the outside of our grounds are all being completely, fully extracted. Every delicious coffee you've ever had, the majority of the flavor you're tasting is actually at 28% extraction, or whatever is maximum for that coffee, because the external area of all of the grinds in that brew that you thought was delicious were at maximum. They were completely extracted. And any number that if you measured that coffee and it read 22%, what you're really saying is, I really enjoyed this coffee because some of it was extracted to 28%, but there was some that the water missed, so the average extraction is probably 22. So full extraction is actually optimal, yes.
Then is there no over-extraction?
There is over-extraction, and that's why I stumbled on the over-extraction column of the previous slide, because over-extraction does occur, but you really have to try. And I'm finding more and more that the flavors that we associate with over-extraction, you really have to try to get them. And normally it's, oh, this coffee's bitter and dry, must be over-extracted, your roasting sucks, is usually what that reason is, or usually what that symptom is for. And dryness, emptiness, you really have to sit well-roasted coffee in a boiling saucepan for 2 minutes to achieve over-extracted flavors. Or you have to run an espresso for minutes. But if you roast coffee perfectly and push water through an espresso machine, push a filter coffee ratio 1:16 through well-roasted coffee grinds in an espresso machine, it's still not over-extracted. So over-extraction probably doesn't really matter that much. It's probably your bad roasting or bad coffee quality, or you were making Ibrick coffee and left it in the sand for too long. But I think it's very rare that anyone has actually tasted truly over-extracted coffee. Maybe little bits have been over-extracted. If you channeled an espresso and then all of the hot water was just going through a tiny little bit, that channel has probably been well over-extracted. But if you're evenly extracting, I think it's pretty much almost impossible to completely over-extract a coffee. And this is really counterintuitive. And it's taken me a long time to even poke my head up and be like, maybe this is actually what's going on. Because I usually get shot down by a lot of people. But this is I'm pretty convinced what's going on. And a lot of people are now becoming convinced of the same thing. Yes?
I've noticed a trend where people tending to be grinding a little bit finer and tamping with less pressure. Would that be tied in with what you were saying there to bring the particle size down? But
maybe.
obviously, if you press hard with fine, you don't get the flow.
I think there's so much pressure from the water once you actually start brewing that tamping pressure is a little bit irrelevant because there's 115 psi for 9 bar. That's if you could tamp at 115 psi, it'd be like gun show. The pressure from the water, I think, completely nullifies any light tamping that you were doing and just brings it to max. So, yeah, I'm not sure. So I did a little experiment because I was like, maybe I'm wrong. So let's science the hell out of this. So what we did was we used a sifter and we ground some coffee and we made 3 fractions of grind sizes. They were 0 to 250 microns, or what I would consider to be very fine particles. Any finer than that and we would have been sifting all day. Then we had 250 to 500 microns, and then 500 microns plus. Now a micron is 1/1000th of a millimeter, so 500 microns is half a millimeter. So this is pretty small. So what we did was we measured out the same weight of each of those different size ranges, put them in cupping bowls, and then poured boiling water on them, the exact same amount of boiling water on each of these little cupping bowls, stirred them vigorously, and then in different cupping bowls, so we didn't take samples from the same bowl, we did a specific bowl for each time, we took a sample of the liquid and then measured the TDS. So this is a pretty good way of understanding how water penetrates a grind and what it does and when it actually starts to come back out again and give you flavor. So at 15 seconds, which was my first waypoint, the larger than 500 micron grinds were at 14% extraction. The 250 to 500s were at just under 20, and the 0 to 250 were at just under 23. And then we measured again at 30 seconds, and the largest grinds had jumped up to 17. The middle fraction was just above 21, and the smallest grinds had only increased a little bit from maybe 22.8 to 23.8, so maybe 1% more. Now, after that, the smallest grinds barely moved again. The largest grinds had also started to plateau quite heavily. So what you would expect to see with the large grinds is that line continuing to go up to meet the smallest grinds, because you would expect that the water would go in deeper and deeper and get more coffee and then come back out again and contribute all of those solubles to the brew, but it didn't. It just kept on lagging, and I kept on going, all the way up to 10 minutes or 600 seconds, and as you can see, the 250 to 500 microns eventually got there. So the water in that case eventually got in. So at the maximum size, 500 microns, it had traveled in 250 microns, because that's the radius from the edge to the center of those grinds, assuming they're spherical, which is the only thing we can assume. And then it traveled all the way back out again, and eventually we got to the same level of extraction as the smallest grinds. But it took 10 minutes. That's why cuppings, I think, taste so great, is because they're probably more evenly extracted because we gave it so long to extract. Now the largest grinds were still only at just above 19.5% extraction after all of that time, which means the water hadn't even touched what was happening on the inside. So this isn't super obvious. This isn't super new. Anyone could have predicted that the large grinds would have a lower extraction yield than the smallest grinds. But what this data showed us was that the outside of the grinds and that first layer that's been penetrated by the water behaves exactly the same no matter what the diameter of your coffee grinds. And if you do some quick maths and figure out what the depth of extraction is, because if we assume the smallest grinds have been completely extracted and our maximum is 24, then you can figure out based on how big the grind particles are, how deep the water's gone in. Because if they're the same density the whole way through and you've extracted half, then you figure out what half the volume of that sphere is in terms of a ring around the outside, and then you know how deep the water's gone. And it was really, really eye-opening, because at every single point where we compared the different fractions of diameters, the water had penetrated 100 microns, almost every single time within plus or minus 10 microns. It was going in 100 microns doing its thing, and not going any deeper, and that's it. So if we look at our grinds again from that previous example, this is really what we're extracting from every grind, is a layer. Now, again, we're assuming they're spherical, and this is a worst case scenario. So it only gets better for this argument if they're not spherical, which is great. We're only extracting 100 microns deep in all of those different coffee grinds, and then the rest is wasted. So that means that the optimal grind setting, absolutely optimal, would be 200 microns maximum, which is ridiculous because any brewer would clog instantly. So,
is there any
you put your hand up?
Sorry. It's been a long fucking day. No, is there any consideration of surface tension within the water and the cell structure of the coffee at all in this?
I don't know. Like that's beyond my pay grade. Yeah.
In a cupping bowl, for example, all your particles are actually at the bottom, and you're actually measuring extraction at the top of it.
We were stirring the hell out of it the whole time. Yeah.
So that means that you actually, what's been extracted from the particle has then been transported away from
Yes.
the particle. So your particle, you've extracted the outside, but it's now a new particle that's smaller. So why does it now continue extracting?
Because the cellulose is still there. It does continue to extract, and that's why that's why that blue line down the bottom continued to increase, because you had erosion occurring. And that's why you see at a certain point in the espresso extraction, your water flow, it sort of goes quicker, and it starts slow, gets quicker, and then plateaus. And once it sort of hits that plateau of flow rate, that's when you've eroded everything that you're going to erode, and now it's just water flowing through cellulose. This is probably because stuff's eroding. 30% of those tunnel walls have been eroded. Now the tunnels are bigger, so the water can get in more easily. So that's that slow increase that we're seeing there. Probably other things happening as well, but it's not. The water just doesn't travel into a maze because it feels like it.
So you never actually have then full solution of your particles, right? You are only extracting part of it, but then the cellulose still remains behind.
Yeah.
Right?
Yeah. Yes.
Would this change the older the coffee gets?
I have no idea. Yeah. I think CO2 probably gets in the way of extraction when it's really fresh, because there's all bubbles and stuff everywhere, especially in espresso. Because I think we normally trended, when we were capturing data from all our espressos every day, the older it got, the higher our extraction yields got, I think was the general trend. Was there yes?
So if we were able to grind to 100 microns and extract at 100 microns,
It'd be glorious. Yeah.
would we be able to use a lot less coffee
Yes.
to produce the same cup?
Oh my God, yes. So much less. Yeah. But I'm not saying 100 microns, I'm saying 200 because it's a radius. So the water can go in to the middle and then come back out again. And it's probably more. It's probably like 250. You know. And it also really depends on how you roasted the coffee. If you smash it with a really high temperature, the bean will expand more. There was a guy who did rad experiments back in the 80s where he roasted coffee and then injected it with mercury to see how porous it was and what the internal volume was. Like real mad scientist shit. And he found all kinds of cool things about how roast affects the expansion of the bean. So I would hazard a guess that if you're a roaster, if you started measuring volume and you were aiming for maximum volume increase without roasting too dark, your porosity would be increasing because you've got the same amount of cellulose. It's now bigger. So your porosity would increase. Now this coffee that we tested was very light. It was roasted by Onyx in the US, and they are on the lightest end that I would enjoy. And that means that it's probably going to be a lot less soluble. So this rule is only for this coffee in this particular way, in this experiment. And if you change the roasting, you might find that you've got a bigger window that you can play with in terms of that depth that the water can actually penetrate the grinds.
So would you expect darker roasts to be possibly increasing the 100?
Yeah, like way more porous. Yeah. And that's usually the case because a lot of people try to under-extract dark roasts because they're so soluble and so readily extracted. And I need to do way more testing to actually figure out what is the spread, where's the average, where does it go to. It's really early days, and I'm sure labs have done this properly, but we're just like, 4 people in an office in Melbourne. Yes? Yeah, it was the coffee we sent out for the subscription. It was a Guatemalan, which means it was probably Caturra, from Finca Insul. It was just the tasty coffee we had on hand in the office at the time because we were sending it out. But I'm not saying that everyone needs to grind super fine tomorrow. And that's the problem here, is that we can't just change how we're grinding our coffee to make them all really small, because everything will clog and it's not going to work. So if we have a look at these electron microscope images, I froth on electron microscope images. You can see these little bars here are 100 microns. And it kind of gives you an idea for how deep the water is actually penetrating into these grinds. And you can see, based on the cell structure of this coffee, how the cell structure and those pores really defines how the water can get into the coffee. Because coffee isn't this beautiful crystalline substance that's just endlessly repeating and perfectly dense. It's really gnarly. It's got little holes and tunnels and bits and bobs and coffee flavor hanging off walls, and it's not optimal for water flow. It's possibly the worst thing for water flow. And this is even more zoomed in. That's 100 microns again, that white line. That's how deep the water's getting in that experiment. You know, it's a couple of pores. Maybe it gets into one pore, finds a hole, gets into the next one and stops. That's it. So it's really tricky for water to get into this stuff. It is not designed for that. So essentially, what I'm saying is over-extraction isn't really a thing. It exists, yes, and it tastes awful, yes, but you're probably not going to encounter it. What you need to do is always aim for more extraction. Now, every time I say this, someone goes, but more extraction doesn't always taste good. And that's because what you're normally doing is you're measuring your coffee, you're grinding too fine, tasting it again, seeing that the extraction went up a little bit, and saying that over-extraction is bad and you shouldn't aim for more. That's like one case in this entire multi-dimensional sphere of how to make coffee extracted more. Yes, it can taste worse when you increase your average extraction, but if you understand how averages work, then you need not be scared about increasing the average if you do it in the right way. So the bad way to do it is to grind so fine that you end up going backwards. So this, I chucked this up on the blog years ago. As you continue to grind finer, your extraction will go up, obviously. Of course it will. And then at a certain point, you hit the maximum amount of extraction that you're going to get with that brewing device, that coffee, that combination of variables. And as you continue to grind finer, you're going to go off a cliff, and your extraction is going to go back down again. So you need to find that little maximum, that local maximum. It's not a local maximum, it's the maximum extraction that you can get from that coffee. And that is always going to be the best tasting coffee, in my opinion. Maybe you like under-extracted coffee, that's cool. I think that's going to be the best tasting representation of that coffee that you can possibly serve, is at that maximum point. Now, a lot of people, as I said, complain that it doesn't always taste better when you increase the extraction. And I would argue either that your roasting sucks, you don't have a palate, or you're doing it the wrong way, because it's always better. So this is what's normally happening when people they have an uneven extraction and they say, Matt, you're an idiot, extracting more is just going to make it taste bitter and awful. What they're already doing is that uneven extraction that I was talking about before. This is one coffee. And as we've learnt, it's not a melange of under-extraction spreading evenly through to over-extraction. It's under-extracted internals of grinds and over-extracted externals. So that's represented with the same colours as before, but we have this line here where it's not tasting great. It's kind of over-extracted and it's not good. If they increase the extraction of this coffee, that has to move even further into the depths of over-extraction before the bulk of their coffee, or maybe half of their coffee, even begins to become well extracted. So of course you would argue that increasing your extraction is bad when it's uneven, because it's already so close to over-extraction and not tasting good, and also already so under-extracted at the same time that you don't have any freedom to move and you're kind of stuck. So of course you don't want to increase it. And if you make your extraction quite even, then it's going to be sitting somewhere in the middle. You've combined both of those, you've doubled its size, and it's now sitting in a reasonable level of extraction. But because you've reduced the amount of space that it takes up on that extraction axis, you're now free to move that tiny bubble of coffee extraction up or down, which means you can bump it all the way up. I don't know what's going on with this slide. All the way up to as close to maximum that you possibly can. And then you're using less coffee, you're extracting more of it, it's more sweet, you have less under-extracted, you have less over-extracted, and it's just more generally delicious. So once you understand that improving the evenness of your coffee to produce more extraction is great, then you really open up an entire new realm of deliciousness. And it's far more freeing than any other variables that you can adjust. So I have practical tips, yes.
What's the highest extraction shot you've ever pulled?
I made at the Malkonig factory in Hamburg, I got to play with their giant industrial grinder that has burrs about like that big. I think it's called like a DK27, and it does tons an hour. And we put in a little 20-gram dose in the top, and it was like, and it just disappeared. We got 3 grams out, but we dialed it in and got 26%, and it was otherworldly. It was bizarre. But I've had similar levels of extraction in espresso, which is frightening, from roller mill grinding as well, for like single serve pods and things like that. So in terms of brewed coffee, you need to treat every grind the same way. Imagine that you've got a wonderful democratic republic, and every single one, or maybe socialist, and every single one of those grinds needs to be treated exactly the same way, all of them. And they need to be the same size, and everything needs to be fair. Agitate and stir. You're not going to over-extract a filter coffee by stirring it at the beginning. That's absolutely ridiculous. You're extracting it for 3 minutes. Stirring it at 10 seconds isn't going to do nothing, except make your extraction more even, which is going to make it more delicious. Agitation and stirring is to get every grind wet ASAP. So just get everything wet. If you see bubbles later, then something was dry and has just become saturated and released CO2. That's a really great indicator in a pour-over or a cupping bowl or whatever that not all of the grinds were wet. Don't grind so fine that flow is choked, because there is that maximum and that decline again. You need to find the max. That's as fine as you can go. And if you do want to sift, he's gone. The sifting man is gone. Oh, there he is. If you want to sift, I would recommend sifting everything larger than 500 microns, because that's the fastest sifting you can do, because that'll just pass straight through and then the boulders are left behind. There's no tapping and shaking and all that kind of stuff. Everything just drops through a 500 micron sieve, except the worst offending boulders. And then you can regrind those if your grinder is appropriate for that, and you'll improve your coffee to no end instantly. In terms of drip, I didn't have time to redo this, but I recommend flatbed brewers more than the cone sort of shape, because there's no reason the water wants to travel all the way down to the bottom of a cone. That seems a little bit preposterous, but flatbed, at least if the water is flowing through one part of the coffee, it has the same level of incentive to flow through every part of the coffee, which just seems to make more simple sense. So double dose and stir it. That's easy. Make sure the grinds are up on the edges. Make sure the water level's never too high, because then it just wants to go through the paper. If you were water and you had the choice of going through coffee or paper, you'd go through paper. So don't pour too high. Keep your agitation and level the same. Like, I see a lot of baristas whipping their little kettles, which is very inconsistent. Just keep it at a consistent height and let gravity do the pin drop for you. In terms of batch brew, if you need to turn off the sensor if you have a new Fetco, so that it doesn't turn off when you take the basket out. There is options for that, or trick it by like cutting out the magnet and gluing it to it. There's ways. And make sure that the number of pulses keeps the coffee wet, but the water height never too high. Like, you don't want to have 3 pulses that completely overblow the basket and then take forever to drain out. You want to just be constantly delivering nice hot water and keeping that level just sitting above the grinds. There's always a minimum dose in batch brewers, where once you go below that minimum dose, the water just goes through the sides and there's no reason for it to go through the coffee. It's really weird. Weigh the water delivery in batch brewers. This has nothing to do with the rest of the lecture, but nobody actually weighs what comes out of their batch brewer and they trust what's on the screen. It's wrong. So weigh at least 5, and then each day weigh 2, and then average it, and that's your brew water weight for the day. And then measure it when the dishwasher's on and be depressed, because it'll be less. And generally with batch brews, just grind coarser. And I know I didn't say to grind coarser, you have to grind finer, but the problem with batch brew is that there's no pressure pushing that water through finely ground coffee. If the water can go out the side, it'll go out the side. So you need to make it as easy for the water to go through the coffee as it is to go through the paper. So that's pretty coarse. In terms of immersion, dump the water in as fast as you can so that the dumping of the water stirs the grind. So you don't need to carefully, drop water in. Just dump it, and then that'll agitate everything for you. Stir it, but don't leave it spinning. I find with AeroPresses, if you leave it spinning, some grinds will be sat still and others will be whizzing around up the top, and they're going to be more extracted than the ones that are still down the bottom. Marginal gains, everyone. Use 2 papers for an AeroPress, it's always better. And the usual inversion is fine. Now, for espresso, everyone thinks I get paid by VST, but he's so stingy. He doesn't give me a cent. VST baskets are way better than everything else. Just use them. They're so cheap and they last forever. They don't last forever. They last for a very long time. If you have a curved tamper, put it on the shelf. It looks nice, and get a flat tamper because your extraction will become uneven with a curved tamper because water doesn't like going through not flat things evenly. Fill your hopper up with espresso grinders. If the bed depth of the coffee before the burrs is different, then your particle size distribution will be different. That's a mad design error. And then distribution, I still have no idea what the best distribution method is. We released some results for that the other day. Some of you might have read it. And we discovered that using the OCD tool, kind of spinny things, is better than doing nothing, but it's just as good as the free method of just like tapping the portafilter with your palm, which is a little bit cheaper than 120 quid or whatever it is over here. But we're working on what is optimal and how do we get there rather than just, that doesn't work, let's do something cheaper. Yes?
Would you argue that even though it's just as effective as tapping, it's more consistent? Or?
That's what we need to do next. We need to test 10 Muppets, baristas, and see if they can actually do it consistently. And then we also need, because the other problem with the testing was that everyone who sent us a distribution tool for testing said, we're not claiming that it does anything, but here it is for testing. So if it doesn't work, we didn't say it worked, but if it did do something, that'd be great if you could tell everyone. And they also said, and make sure that it's evenly distributed before you use the tool. So to test the OCD based on what they recommend to use the OCD with, we literally had to do Stockfleth before, or whatever that is, before we use the OCD. So anyway, it's all very silly. What we are working on is this silly thing, which looks like a murder weapon. That kind of like punctures the coffee. And it's not as much about needles making paths through the coffee as it is adding so much volume to the bed of grinds that the grinds have to move to accommodate them. And they move sideways because there's no reason that they can't move down, and they're probably not going to move up unless they have to. So we're kind of calling it sideways tamping. And honestly, I think it's the silliest thing when you just like, well, it's this thing that sticks holes in the coffee. But on most of our tests so far, our extraction yields increased by 2%, which is the largest increase I've ever seen since going to a good flat burr grinder or moving from a curve to a flat tamper. So I don't care what it looks like. If it does the job and it increases our espresso extractions by 2% and wins every blind tasting that we've done so far, it's doing something, so I'll sell it, and it'll make your coffee taste better if you want to use it. But we're still testing it. We're still trying to figure out exactly what it does, and does it not work in some cases as well. So we're still a little while away from actually releasing it. I still have no idea if the sideways tamping thing is even real or not. But if blind taste tests and extraction yields are consistent across the board, we will start manufacturing something like this. And it's obviously not for high volume cafes. That's an ugly prototype version that we just busted out in a week. It'll look much better than that. But if it does work, we'll release why we think it works, and people can choose for themselves. Yeah, it's a weird thing, espresso. So, game plan from now on, after tonight, is more extraction. That's pretty obvious. Even more extraction than you just did until it's worse, and then take a little step backwards. So always more, more, until it tastes bad, and then dial it back a little bit. And I promise you that's the best cup of coffee that you can possibly make. So that seems pretty simple. Now, here's the silly part of tonight. It's all been value up until now. We just released an online course that is pretty much the stuff I talked about tonight in detail, and we go into algebra in terms of how to manipulate all the different aspects of a coffee brew. We go into extraction theory. We have spreadsheets and calculators and tools and all kinds of stuff. This is what Barista Hustle is mainly sort of going to be focusing on now, is online education. And I think there's already 400 students in there that have finished or already started the course. And we're getting very good reviews, and we're continually updating as people ask questions. So it is more like a living document, this first course. So that's up and available. Get your managers to buy it for you. Or we're going to continue to offer more courses. We want to get into doing a barista or cafe financial literacy course, and try to tailor it to each major sort of area, so that if your baristas or if your managers or cafe owners and your staff have done a course like this, hopefully they can make your business more profitable and everyone can make more money. We want to do an advanced espresso course. So this is what we talked about tonight was kind of like a meta level extraction, not necessarily filter, not necessarily espresso. We want to do an espresso specific course that goes super deep. We have a lot of research equipment arriving so we can actually figure out what the hell's going on with espresso. We want to do a filter coffee course, all kinds of stuff. Because it turned out that releasing things for free on a blog is cool, but releasing everything for free on a blog doesn't pay any salaries and leads to things not going places, because that's how the internet works these days. So we decided to change tack and go down the very professional, very advanced courses online and certification route, because education is pretty lacking in the coffee industry. And you don't have to do it, but I think they're pretty good courses, and they're pretty advanced and relevant compared to a lot of the incumbents that are out there at the moment. So that's the little silly part of tonight. Now for the questions. Now I have a rule about questions at question times at talks. If your first sentence doesn't finish with a question mark, you've surrendered your question. That's the rule.
What's the second rule?
If there was a second sentence, then you also surrendered your question. Yeah. We don't. The rest of the people in this room don't want to hear your story. And question time isn't necessarily about sounding smart because you asked a smart question. It's about figuring stuff out. So many question sessions get derailed because everyone wants to show everyone how smart they are by answering the question they already know the answer to. But I'd much prefer to answer questions that you don't know the answer to, because then everyone learns. So yeah, anyone can ask anything if you like. Yes?
Worst water.
Worst water? Yeah. London's up there, but I think Copenhagen takes the winner for the worst tap water. It's like 1,200 ppm. It's like more than Evian.
Do you not find that works better for darker roasts?
That's a lot of stuff in your water. Like that's oceanic. You don't need that much for dark roasts. Not even. Maybe 2 orders of magnitude less would be acceptable still. Yeah.
In terms of the mix of calcium, magnesium, I'm struggling myself with that.
We've got a bunch of different. Have you read the articles that we put up about water chemistry? And just start experimenting with that. We made a chart with lots of different points and different combinations that represent different standards, but also different cities that have good coffee cultures. And you can start experimenting by with 2 concentrates that we designed so that each gram of concentrate equals 1 milligram per litre of the eventual chemical. And if you start playing around with those with one coffee and making different water recipes, you can really start to understand how the knobs on that Etch-a-Sketch actually move flavour. The only way to do it is just to do it. Yes. Just give it a crack. Get a couple of mates, buy some bath salts, have a bath party afterwards or something, have a spa, and just have some fun. Yeah. Yes.
In that water chemistry section, why didn't you talk, or chose not to talk about calcium carbonate?
Because making calcium into solution is really hard. Unless water's so weird. If it's not already in the water and it's like slowly dissolved in there over eons, and that's a natural water source, you can't just jam calcium into water. It's really hard, and it screws up other chemistries as well. It's like you do one thing in water and then 10 other things will change, and then you have to it's like herding cats every time you change one variable. So the magnesium, most people who have played around with coffee chemistry and have played with magnesium have been like, actually magnesium tastes a lot better than calcium does. So we figured for ease of use, go to the hardware store, pick it up, we'd just go with those chemicals. Yeah. Ease of use and exploration was the biggest thing that we wanted to do there, for sure. Yeah, cool. Anyone else? Yeah, out the back.
What do you think about double grinding? Grinding first course and after that to the design?
Well, they do that in roller mills, because a roller mill will usually have 3 sets of rollers, so it's double regrinding. I would regrind boulders after you sifted them out, but generally I would advise against regrinding because the amount of torque required by the grinder motor to regrind grounds and get them through would normally stall the motor, and if your grinder isn't designed correctly, that'll damage it, or it'll overheat, or something will happen. And regrinding grinds means that there's grinds where there were beans in the pre-grinding stage, and then it gets really messy. So, I don't know, it's not great. Just grind finer. Yes?
EK43 espresso shots.
Yes.
Get above 22, 23 seconds.
Are you struggling to get it slow enough? Is it going really quick and you're at the finest setting? Your burrs are not aligned, so you need to align your burrs. At the moment, they're like this, and they're sort of spinning off axis, and that means that you're getting a mix of fine and coarser grinds. If you make them parallel, you can make them, on average, get a lot closer. So we have a guide for that as well on our YouTube channel or something, on how to align them with shims. And it takes about an hour, and it sucks, but it's totally worth it because your coffee will be instantly better and more even and taste great. And you'll have more freedom in terms of the grind setting you can use.
So it can go higher than 23 seconds?
Absolutely, yeah. And especially if you're at the finest setting, that means something's wrong. You should be at about 2:30 to 3 o'clock. Wait, no, 3 o'clock's maximum. No, just after 3 o'clock's maximum. You should be at like 2:15 to 2:45 o'clock. Yeah. 1 to 2 o'clock, sure. Yeah. Was there a question over here? Yeah.
After freshly roasting coffee, how long should you leave it before grinding it?
Once it tastes good. Yeah.
Is there a couple of days now?
No, because every coffee degasses slightly differently in how you roast it as well. So whenever it tastes good. Yeah. Yeah. There's a lot of masturbation around roast date, optimal roast date time, and I think is could be simplified to when does it taste good? Yeah. Neat. Yes.
You talk about doing a lot of research, and obviously you've been measuring things and making graphs. Are you getting together with scientists or trying to publish papers, trying to add some rigor?
Yeah. We usually run it, whenever we do anything stats related or protocol related, we run it past some peers, but it's not a formal peer review process. At the moment, we did start looking into that, and I am an author on a paper about grind size analysis. But I think the amount of value that I can, or that we at Barista Hustle can create, and the speed at which we can move in terms of just dabbling in different things to see what's going on. How can we optimize this very quickly? How can we optimize that? We can probably do 10 to 100 times more value, or we can create 10 to 100 times more value for the coffee industry by being a little bit quick and reckless, honestly, compared to very formal peer-reviewed stuff, which is very slow. And yes, our P would be closer to 0.05, or we'd improve it if we did a heap more sample sets. But I think there is a balance of how quick and reckless we can be. This isn't medicine, so we're not going to kill anyone, I hope. And I think that we can create a lot of net utility by doing these experiments the way we're doing them, asking a couple of scientists, do you think this is ridiculous? And they're like, no, give it a crack, and then publishing those results and moving on. We can help a lot more people and move things a lot more quickly. And if UC Davis and SCA want to formalize stuff afterwards and lock it all in, great. But I think we're creating more. I'm just trying to create value. Like every meeting we have, I'm like, more value. How do we move things forward quickly? And peer review and formal stuff like that, because it is so structured and there is such a process that you have to slowly go through, it just slows things down, and we wouldn't be profitable anymore. We'd have to start getting funding in other ways, and everyone here would be bored because I'd be doing the same speech for 3 years, because that's all we'd be able to focus on is the one paper for 3 years or whatever it was. So I wish that it was easier to do peer-reviewed, published papers. That'd be amazing, but fuck, are they expensive? Yes?
A bit more off topic and current. What are your thoughts on California possibly putting cancer warnings on coffee because of the acrylamide that's in the roasted beans?
Yeah, I mean, acrylamide is a carcinogen, but so is everything. And there's background radiation in this room right now that's probably killing us too. Yeah, I think California's probably the most nanny state, but also they've done some pretty valuable stuff for citizens in terms of protecting them. Like, they're pretty zealous. I would say overzealous maybe, but sometimes they really do a great job.
Do you think it could force change within the coffee industry to change the way people roast and stuff?
Yeah. I don't know, what temperature is acrylamide created at? 230 or something? Yeah, I don't know.
I'm not sure what happens when it breaks down again, but I don't know where or when. And that's why.
Oh, just keep roasting even further and then it's gone. Yeah, right.
It's only really in light roast, but I don't know much about it.
Yeah, right. Yeah, I mean, there's so many carcinogens in the world, and every week another paper comes out that is a meta-study of coffee drinkers, and each week it veers towards it's going to kill you or it doesn't kill you. And there's a lot of other things that have a much higher confidence interval of it's probably going to kill you. So, I don't know. It'll probably be on BuzzFeed for a year afterwards, and then everyone will forget about it because they're not going to give up coffee. I mean, there's so many other products in the state of California that have this product is known to cause birth defects, et cetera, and people are still chugging it. So, yeah, I don't know. Maybe sales will drop and matcha, what are they? Turmeric lattes will take off for a month. I don't know. Yes?
So if I'm grinding finer,
Yep.
start tasting shit, go
Yep.
back, then would I look at, if I still wanted to get more extraction, would it be silly to then go back to yield and increase that, or that would just make it...
You mean yield as in more water through the
More
coffee?
water, sorry.
Yeah, but then you'll sacrifice, you'll have less strength. Yep.
Yeah.
And that's always the compromise. You've got your seesaw that you want to balance on. If you're at the point where you're like, I don't want this to be any weaker, and I am grinding as fine as I can, that's when you start ruthlessly going through every other possible thing. How did we distribute it? How's the water going through it? Did something else happen? What's the shower screen doing? What's the basket doing? How did we, and just keep going, keep chipping away at how to make this more even, and you'll notice that your extraction and strength simultaneously go up when you're at that maximum, and then you do a good job with other things like distribution. They'll both move up together, and that's a win. Yes.
What effect does water temperature have espresso in terms of extraction?
Well, the Arrhenius equation, which is like the basic, if you increase temperature, you extract more stuff. You know, sort of basic equation is every 10 degrees Celsius, as a rule of thumb, will double your rate of extraction. So that's the easy answer.
Should we just keep cranking it up?
I mean, make it as hot as you can so it still tastes good, because you could pull faster shots and then you're more efficient. So, great. So if your coffee starts to taste terrible at 96, no matter what you do, bring it down. But if your coffee still tastes great at 96, then you can pull faster shots and be more efficient and make more money. And laugh all the way to the bank with your, I don't know, $5 extra a day or something. Yeah, sweet. Yes?
What do you think about blowing out the chaff after grinding? Does that cause any flavor?
I want California to put a food warning on that before they put it on acrylamide. Because that's like, you may as well just spit on the coffee if you're going to blow it.
Yeah. I'm just saying,
yeah.
removing it more.
Yeah, it tastes less like carrot when you do that. Like, chaff tastes pretty bad. Normally it should come out from the roasting. Like, if you've still got a lot of chaff in your grinds after roasting, then you probably roast too light. That's a very rule of thumb. But if you need to be blowing it off, then that's a problem, I think. Or there's not enough movement or airflow in the roaster or something's going on. Yeah. And what's the time, Nick, maybe?
I think we're getting pretty close to
we nailed it.
Pretty fun evening.
Nice.
Yeah.